14.2 Short-run production. Short-run and long-run. The key influence on cost is the quantity of output that the firm produces per period. The greater the output rate, the higher is the total cost of production. But the effect of a change in production on cost depends on how soon the firm wants to act. A firm that plans to change its output rate tomorrow has fewer options than a firm that plans ahead and intends to change its production 6 months from now. To study the relationship between a firm's output decision and its cost, we distinguish between two decision time frames, the short run, the long run. The short run, that is fixed plant. The short run is a time frame in which the quantities of some resources are fixed. For most firms, for fixed resources are the firm's technology and capital, its equipment and buildings. The management organization is also fixed in the short run. The fixed resources that a firm uses are its fixed factors of production or fixed cost, and the resources it can vary are its variable factors of production or variable costs. The collection of fixed resources is the firm's plant. So, in the short run, a firm's plant is fixed. Sam's Smoothies plant is its blenders, refrigerators, and shop. Sam's cannot change these inputs in the short run. An electric power utility can't change the number of generator it uses in the short run. An airport can't change the number of runways, terminal buildings, and traffic control facilities in the short run. To increase output in the short run, a firm must increase the quantity of variable factor it uses. Labor is usually the variable factor of production. To produce more smoothies, Sam must hire more labor. Similarly, to increase the production of electricity, a utility must hire more engineers and run its generators for longer hours. To increase the volume of traffic it handles, an airport must hire more check-in clerks, cargo handlers, and air traffic controllers. Short-run decisions are easily reversed. A firm can increase or decrease output in the short run by increasing or decreasing the number of labor hours it hires. The long run variable plant. The long run is a time frame in which the quantities of all resources can be varied. That is, the long run is a period in which the firm can change its plant. To increase output in the long run, a firm can increase the size of its plant. Sam's Smoothies can install more blenders and refrigerators and increase the size of its shop. An electric power utility can install more generators, and an airport can build more runways, terminals, and traffic control facilities. Long-run decisions are not easily reversed. Once a firm buys a free plant, its resale value is usually much less than the amount the firm paid for it. The fall in value is economic depreciation. It is called a sunk cost to emphasize that it is irrelevant to the firm's decisions. Only the short-run cost of changing its labor inputs and the long-run cost of changing its plant size are relevant to a firm's decision. Short-run production. To increase the output of a fixed plant, a firm must increase the quantity of labor it employs. We describe the relationship between output and quantity of labor employed by using three related concepts: total product, marginal product, and average product. Total product is the total quantity of a good produced in a given period. Total product is an output rate, the number of units produced per unit of time, for example, per hour, day, or week. Total product changes as the quantity of labor employed increases. The total product curve is a short-run curve, meaning that technology and all inputs except labor are held constant. We illustrate this relationship as a total product schedule and total product curve. The total product schedule lists the maximum quantities of smoothies per hour that Sam can produce with her existing plant at each quantity of labor. Point A through H on the TP curve corresponds to the columns in the table. The total product curve separates attainable output from the unattainable outputs. Points below the TP curve are inefficient. The orange area, they use more labor than necessary for a given level of output. Points in the TP curves are efficient. At the lower end, where labor and output are low, the curve is convex. on the TP curve. The production is increasing at an increasing rate. Teamwork and specialization leads to increased productivity. Additional workers very efficiently use the available fixed inputs. In the concave portion, production increases at a decreasing rate because additional laborers are less able to use the plant and other fixed inputs efficiently. At some point, total product hits a maximum. After the maximum, additional labor becomes inefficient and output falls. In fact, employees may be getting in each other's way and hindering production, causing total product to decrease. Marginal product. Marginal product is the change in total product that results from a 1 unit increase in the quantity of labor employed. It tells us the contribution to total product of adding one additional worker. When the quantity of labor increases by more than one worker, we calculate marginal product as marginal product equals change in total product over change in quantity of labor. Figure shows Sam's smoothie's marginal product curve MP and its relationship with the total product curve. As the quantity of labor increases from 1 to 3 workers, marginal product increases. But as more than 3 workers are employed, marginal product decreases. When the 7th worker is employed, marginal product is negative. The relationship between TP and MP is explained through law of variable proportions. In the figure in the first part, as long as TP increases at an increasing rate, MP also increases. This goes on till MP reaches its maximum or TP is at the point of inflection. In the second part, TP increases at a diminishing rate, MP declines. This continues till the point where TP is at its highest. Then MP becomes 0. In the third part, TP starts decreasing, MP becomes negative. This happens after 7th worker is hired. TP and MP curve share a common feature irrespective of any business firm, that is, increasing marginal returns initially, decreasing marginal returns eventually. Increasing marginal returns initially occurs when the marginal product of an additional worker exceeds the marginal product of the previous worker. The source of increasing marginal returns is increased specialization and greater division of labor in the production process. Decreasing marginal returns. All the production process reaches a point of decreasing marginal returns. Decreasing marginal returns occurs when the marginal product of an additional worker is less than the marginal product of the previous worker. Decreasing marginal returns arise from the fact that more and more workers use the same equipment and workplace. As more workers are employed, there is less and less that is productive for the additional workers to do. For example, if Samantha hires a 4th worker, output increases but not as much as it did when she hired the 3rd worker. In this case, 3 workers exhaust all the possible gains from specialization and division of labor. By hiring a 4th worker, Sam's produces more smoothies per hour, but the equipment being operated is closer to its limits. Sometimes the 4th worker has nothing to do because the machines are running without the need for further attention. Hiring 8 more workers continue to increase output but by successive smaller amounts until Samantha hires a 6th worker, at which point total products stop rising. Add the 7th worker and the workplace is so congested that the workers get in each other's way and total product falls. Therefore, the law of diminishing returns states that as a firm uses more of variable factor of production with a given quantity of fixed factors of production, the marginal product of the variable factor eventually decreases. Average product is the total product per worker employed. It is calculated as average product equals total product over quantity of labor. Another name for average product is productivity. The table calculates the average product of labor AP. For example, when the quantity of labor is 3 workers, total product is 6 gallons an hour. So average product is 6 gallons per 3 workers is equal to 2 gallons a worker. Figure shows relationship between average product and the marginal product. In the figure, average product increases from 1 to 3 workers, its maximum value, but then decreases as yet more workers are employed. The average product is largest when average product and marginal product are equal. That is, the marginal product curve cuts the average product curve at the point of maximum average product. Relationship between average product and the marginal product. As long as MP is higher than AP increases or slopes upwards as more labor is employed. MP curve lies above AP curve. MP is equal to AP at the highest point of AP, that is when AP is at its maximum. MP curve cuts AP curve from above. When MP is less than AP also starts to fall. Thereafter, both AP and MP fall. MP curve lies below the AP curve. But MP becomes negative. AP remains positive. MP falls at a faster rate as compared to AP.